Space is vast. It's very, very big. When we look up at the night sky, we see just a tiny fraction of the universe. The distances between stars and galaxies are almost incomprehensible. Even the closest star to our solar system, Proxima Centauri, is over 4 light-years away. That's about 24 trillion miles. To explore these vast distances, we need innovative solutions. Traveling across such huge distances needs new ways to power spacecraft. Traditional rocket fuel is not practical for interstellar travel because it would require an enormous amount of fuel, making the spacecraft too heavy. Scientists and engineers are constantly exploring alternative propulsion methods that could make interstellar travel feasible. One idea is to use lightsails. This concept, which might sound like science fiction, is actually based on solid scientific principles. Lightsails, also known as solar sails, harness the power of light to propel spacecraft. The idea is to use the pressure exerted by photons, the particles of light, to push the spacecraft forward. Light sails are like giant sails for space. Imagine a sailboat on the ocean, but instead of catching the wind, these sails catch light. When light particles hit the sail, they transfer their momentum to it, creating a small but continuous force that propels the spacecraft. But instead of wind, they use light itself to move. This light can come from the sun or from powerful lasers aimed at the sail from Earth or other locations in space. The continuous stream of photons hitting the sail provides a steady push, allowing the spacecraft to gradually build up speed. Imagine a large, thin sheet of material, like a giant mirror. This sheet is made from highly reflective materials designed to maximize the amount of light that bounces off its surface. The more reflective the sail, the more efficient it is at converting light into propulsion. Sunlight bounces off this mirror and gives the sail a tiny push. Each photon that strikes the sail imparts a minuscule amount of momentum. While each push is incredibly small, the cumulative effect over time can be significant, especially in the frictionless environment of space. This push is small, but it's continuous. Unlike traditional rockets that burn fuel in short bursts, light sails provide a constant force. This means that over long periods, the spacecraft can achieve substantial speeds, making them ideal for long-distance space travel. Over time, the spacecraft can reach very high speeds. In theory, a light sail-powered spacecraft could travel at a significant fraction of the speed of light, allowing us to explore distant stars and possibly even other galaxies. The journey would still take many years, but light sails offer a promising step towards making interstellar travel a reality. Light is made of tiny packets of energy called photons. When photons hit a surface, they transfer a small amount of momentum. This is called photon pressure. Think of a bowling ball hitting a bowling pin. The ball transfers some of its momentum to the pin, making it move. Photons do the same thing, but on a much smaller scale. One challenge with light sails is keeping them stable. Space is not a perfect vacuum. There are tiny particles and radiation that can cause the sail to wrinkle or tear. Imagine a plastic bag floating in the wind. The bag can easily get blown around and lose its shape. Light sails face a similar problem in space. Scientists are working on new materials to make light sails stronger and more stable. These materials are not just any ordinary substances, they are meticulously engineered at the microscopic level to achieve remarkable properties. The goal is to create light sails that can withstand the harsh conditions of space travel, including intense radiation and extreme temperatures. This involves a deep understanding of material science and nanotechnology. One promising approach is to use nanostructured surfaces. These surfaces are designed with patterns at the nanometer scale, which is a billionth of a meter. By manipulating materials at this incredibly small scale, scientists can create surfaces with unique properties that are not found in nature. This opens up a world of possibilities for enhancing the performance and durability of light sails. These surfaces have tiny patterns that are smaller than the wavelength of light. This means they can interact with light in very specific ways, such as reflecting, absorbing, or even bending it. By carefully designing these patterns, scientists can control how light interacts with the material, which is crucial for the efficiency of light sails. The ability to manipulate light at such a small scale is a game changer for space exploration. Think of the surface of a lotus leaf. The lotus leaf is famous for its ability to repel water, a phenomenon known as the lotus effect. This effect is due to the microscopic bumps on the leaf's surface, which prevent water from spreading out and sticking. Instead, water droplets bead up and roll off easily, keeping the leaf clean and dry. This natural phenomenon has inspired scientists to create similar nanostructured surfaces. Water droplets bead up and roll off easily because of the leaf's microscopic bumps. By mimicking this natural design, scientists can create materials that repel water, dust, and even bacteria. This has significant implications for light sails, as it means they can remain clean and functional for longer periods, even in the harsh environment of space. The self-cleaning properties of these surfaces are just one of the many benefits of nanostructuring. Nanostructured surfaces can have similar properties, repelling dust and radiation. This is particularly important for light sails, which need to maintain their efficiency and integrity over long durations in space. By incorporating these advanced materials, scientists are paving the way for more reliable and effective space travel. The future of light sails looks promising, thanks to the tiny structures that make a big impact. Section 5. Mirrors of the future. These nanostructured surfaces can also be designed to reflect light more efficiently. This means the light sail can get more push from the same amount of sunlight. Imagine a mirror that reflects almost all of the light that hits it. This would be a very efficient way to harness the power of sunlight for propulsion. Section 6. Smooth sailing ahead. Another advantage of nanostructured surfaces is their self-healing capabilities. If the sail is damaged by a micrometeoroid, the material can actually repair itself. Think of a cut on your skin. Your body can heal the wound over time. Some nanostructured materials have similar self-healing properties. Section 7. A test of patience. Lightsail technology is still in its early stages. Several small-scale experiments have been conducted in space with promising results. But we need more research and development to build larger, more ambitious light sails. Imagine the first airplanes. They were small and could only fly short distances. Light sails are at a similar stage of development. Section 8. Reaching for the stars. Light sails have the potential to revolutionize space travel. They could enable us to explore the solar system and beyond without the need for heavy and expensive rocket fuel. Imagine a spacecraft that can travel at a significant fraction of the speed of light. This would open up new possibilities for interstellar exploration. Section 9. A universe of possibilities. The development of light sail technology is a testament to human ingenuity. This innovative technology uses the pressure of light from stars or lasers to propel spacecraft through the vacuum of space. Unlike traditional propulsion methods that rely on fuel, light sails offer a sustainable and efficient way to travel vast distances. Imagine a spacecraft sailing through the cosmos, powered solely by the light of distant stars. This concept, once the stuff of science fiction, is now becoming a reality thanks to the tireless efforts of scientists and engineers around the world. By harnessing the power of light, we may one day be able to explore the cosmos in ways we can only dream of today. Light sails could enable missions to the farthest reaches of our solar system and beyond, opening up new frontiers for exploration and discovery. The potential applications of this technology are vast, from sending probes to distant exoplanets to establishing interstellar communication networks. The dream of interstellar travel, once confined to the pages of science fiction novels, is now within our grasp. Think of all the wonders that await us in the universe. From the breathtaking beauty of distant galaxies to the mysterious phenomena of black holes and neutron stars, the cosmos is filled with marvels that we are only beginning to understand. Lightsail technology could be the key to unlocking these mysteries, allowing us to explore regions of space that were previously inaccessible. The universe is vast and full of potential, and with light sails, we are on the brink of a new era of space exploration. Light sails could be our key to unlocking these mysteries. As we continue to develop and refine this technology, we move closer to a future where humanity can journey to the stars. The possibilities are endless, and the adventure is just beginning. With each new advancement, we take another step towards realizing our dreams of exploring the universe and uncovering its secrets. The future of space exploration is bright, and light sails are leading the way.